All right, good to see everybody. Welcome to our next webinar for the Great Plains Stormwater Center of Excellence here for the month of August. My name is Jason Vogel. I'm the director of the Great Plains Stormwater Center of Excellence, and really excited to see everybody on here. I see the numbers still climbing, and that's awesome. Quick announcement or a little bit, we do have a Q&A part over here where you guys can put in questions along the way. We also currently have open our call for abstracts for the Great Plains Stormwater Conference, which will be in Oklahoma City at the end of next March 29th through April 1st. We're really excited for that. And the abstracts for that are due next Monday. We put a 1-week extension on that, so we'd be excited to have anybody that's on here put in an abstract and see a whole bunch of people in Oklahoma City next March. But with that, we'll go ahead and transition over to our presentation. Today we have David, Holly, and Candace from the Mile High Flood District from the western edge of the Great Plains. Really excited to see their presentation. They're doing a ton of really cool stuff, and hopefully it's something that y'all will have questions on at the end, and we'll get a chance for interaction then. So with that, I'll turn it over to y'all.
Great, thank you so much. Can you hear me? Okay, perfect. And you can see the slides?
Yep, we can see the slides.
Great, perfect. All right, I don't want to get carried away. Well, thank you everybody for having us. Dave, Holly, and Candace, and you can see our titles on the slide there. We're all physically in the same room here, so we're going to do little musical chairs in between presenters. But whenever I think of Oklahoma, I grew up outside of Lincoln, Nebraska, so whenever I think of Oklahoma, I think about Oklahoma versus Nebraska football in the 1980s and just how good we all had it once. And then I went to the University of Florida, and actually Holly went to the University of Florida as well. And then Candace went to the University of Tennessee. So it's just really weird that Oklahoma's in the SEC, and it just feels all wrong. But I don't know. I still follow, but it's just weird having Nebraska play Iowa instead of Oklahoma on Thanksgiving. But we had a good ones. All right, so I'm going to go ahead and get into the presentation here. So let's see. I just want to click on one more button. All right, so we are a special district that encompasses 1,600 square miles around the greater Metro Denver area, and we work to protect people, property, and our environment from the devastating impacts of floods and the chronic impacts of urbanization. We were created in 1969 as a response to a major flood along the South Platte River, which is our main stem. And we realized that the fragmented every community for themselves approach to floodplain management was not a recipe for success. So we facilitate the rhyme and reason to how waterways are managed as they cross 40 city and county boundaries. That includes over 3,000 miles of regional waterways, so pretty much anything big enough to have a name. We have a yearly budget of around $100 million that comes from a mill levy on property taxes. So a little more geography. The mountains limit urbanization to the west, but we have lots of land left to potentially urbanize in the east if we can find enough drinking water, which is not a certainty. We have some older parts of town too, areas built before we started planning around flood risk in the 1970s. So it's an interesting mixture of older at-risk neighborhoods, total greenfield development, and then everything in between. So that's who we are and where we are. I'll also describe our services. With floodplain management, we identify and communicate flood risk. We have what's called a cooperating technical partnership with FEMA that gives us local management of changes to floodplain maps. So we identify the risk, but then we need to know what can be done about it. So with master planning, we study streams and watersheds to identify system-wide goals and potential improvements so that as both public and private projects get built, we know how it all works together. With development services, land development still builds more new waterway infrastructure than we do. So we play a big role in working with local government partners to preserve stream corridors and ensure that private dollars are building quality infrastructure that taxpayers will inherit. Capital improvements. This is where we fund, design, and build public infrastructure projects, typically for flood mitigation or stream restoration. Every project we build is in partnership with the local government. So we generally let them set the priorities, but we require that they fund at least 50% of the cost. Stream management is where we maintain and manage functionality of our systems on a yearly basis, including vegetation management, infrastructure repairs, and preserving flood carrying capacity. We do fund this work at 100%. We also purchase flood-prone properties in high-risk areas from willing sellers. We probably do around 3 or 4 of these per year. Flood warning includes daily forecasting and a network of rain and stream gauges to equip emergency managers with real-time information. So that green pipe on the right has a tipping bucket rain gauge at the top and then a flow gauge in the stream nearby, and it's all connected to a cellular network. With research and development, we create engineering criteria, tools, techniques, and standards for the industry. Here you're looking at research and testing related to safety grates that Holly will share more about later. Education and outreach. Here, our goal is to elevate our fellow industry professionals and inform the public and policymakers. Now, when it comes to results we've been able to achieve, one of the ways I like to describe that is that our impact makes the community safer, healthier, and more livable. So let me give you a few examples, starting with safety. Now, Westerly Creek in Denver has an interesting history. This photo shows an engineered channel that used to sit under the runways of the old Stapleton Airport. As the area redeveloped, space was preserved for flood flows to spread out. So resilience was largely achieved with the design here with healthy vegetation and buried riprap. I like to call this infrastructure that looks like nature. Now, this used to be buried under a runway. Now I'm going to show you a series of photos taken from this bridge. Here you can see the photo vantage point a little better. That ped bridge in the distance will show up in all these photos. So here's an initial photo on a sunny day. And here is the exact same view at the height of the 2013 flood when we had 100-year flows from 16 inches of rain. This photo was taken the very next day, and then back to the first photo, which was actually taken 8 months post-flood. So after a 100-year flood, there was literally nothing to fix here, and I think this demonstrates one of the ways we've made the community safer. We also make the community healthier in a number of different ways through ecology, recreation, shade, access to nature, but I'll share a quick water quality story. We're not an MS4, but with our research and development group, we provide resources to help our MS4 partners. Candace will share some examples later. But sometimes the most impact you can have on water quality is in the receiving stream rather than in the watershed. And here we're looking at a restoration project on Cherry Creek. This project was studied to quantify how much the stream restoration reduces pollution. So prior to the project, the stream was eroding like crazy and sending all sorts of sediment and pollutants downstream through the system. And this shows the list of contaminants that no longer make their way downstream on a yearly basis because of this restoration. So this is an example of one of the ways we make the community healthier. But we also make the community more livable. You know, old school approaches like this photo focused almost solely on flood conveyance, move as much water as possible from point A to point B. The secondary focus was stability, trying to prevent erosion or incision, which is why you see all the concrete. And we've come to realize that waterway infrastructure has the opportunity to create daily value beyond, in addition to flood conveyance and clean water. Our projects can create numerous ecological and social benefits. We can work with nature rather than trying to strictly control it. So this series of images shows you trails and open space, wildlife, recreation, access to nature. So we take very seriously our role in shaping these special places where land, water, and people come together. And these wonderful places don't require an entrance fee. So we take a lot of pride in creating projects that allow many functions to occupy the same space because it creates lasting benefits, both for the community and the environment. And we found it's possible to accomplish this layering of goals even at the end of a pipe outfall like this one, where we ran the daily flows through a series of constructed planters to have a cleansing effect on the water and also to serve as an amenity for trail users to stop and look at. And yes, it can handle a major flood really well, which we had to plan for that also. This costs perhaps 10 to 20% more than a traditional outfall would have cost, but I think we would say it's definitely worth it. Now, projects like this one were created pretty much by an owner, an engineer, and a contractor working together. But when we expand our idea of what's possible and start thinking about placemaking and community values, habitat, recreation, the team gets more complicated. And this graphic is showing you how complicated just the project team can get. So we've done a few things over time to help us navigate that complexities. And one of those is the urban stream framework. So flood protection is largely driven by hydrology and hydraulics. These are foundational, but I think of them as the black and white aspects of our work. Not necessarily easy, but they're quantifiable and mathematical in ways that we're used to. So upon this black and white foundation, we also consider these other elements of urban stream function. We call these the 5 elements. So if H and H are black and white, then the other elements bring color. It's the browns, the greens, all the other colors of the rainbow. This combination takes projects from good to great. It makes them community treasures and not just utilities. So when we're talking about multifunction, these elements are where we start, and then we balance them with capital and life cycle costs and the context we're working in. We don't consider any of these as nice to have. We feel responsible for finding the optimal combination for a given project. And I don't have time to get into much detail, but we take the 5 elements, lay out common performance indicators, and then within each of these, we look at a wide array of quantifiable metrics to define how much value, how much function we might gain per dollar invested for alternatives we're considering. We come up with a project-specific constellation of success metrics to measure different versions of the same project against itself. So this helps us understand value beyond, in addition to flood protection and clean water. So our goal shouldn't be to build the cheapest projects possible. We're looking for that sweet spot between cost and value. So one example on this project, the original channel and the street median could only carry around a 2-year flood. And then the right-of-way was used for anything bigger. So in a flood, it was hard to tell where the street stopped and the channel started. So we ended up with situations like this. We just wrapped up construction of this entire corridor from fence line to fence line, and over time, this is going to grow into a beautiful tree line median. The entire 100-year flood now fits in the channel. There's lots of buried riprap along here to give it stability, but resilience isn't just built, it's also grown. This project was impacting a polygon of public land. There were many different choices about how we could reallocate that public space. The existing road section was very focused on cars, not much room for hydraulics, pedestrians, or cyclists. No habitat, no shade, and this shows it diagrammed in cross-section. So how can we make better use of the land we have to work with? So using the street to carry riverine flow was a non-starter because of the stranded car we saw earlier, so that gave us a starting point. Here were the 2 cross-section alternatives we narrowed it down to from 16 we considered. We compared the functional performance for each of these functions like hydraulics and ecology, pedestrians, bikes, moving cars, parked cars, tree canopy. The bottom option puts some of the major conveyance underground. So the costs were similar, so we chose the middle option. This excerpt shows a high-level depiction of the candy buttons we used to compare different options we were choosing from. There was extensive community engagement to get their input, so the we included the public. I got just about a minute or two and I'll be wrapping up. A public space being great will be judged in the eyes of the public who live near it. So we want this outdoor space to feel like home to them. So that means they needed to feel like they were part of the process. So notice how conveyance was just one of several diverse variables we considered. And the design project manager on this is a guy I admire greatly. And he said this project achieved the best balance of any project he'd ever worked on. And it was a balancing of value. Now, bringing a multidisciplinary group of people together to figure out a project like this was really challenging. It's very messy. It's very human. So a couple of programs we've invested in include a stream management academy and a construction management academy. With the Stream Management Academy, this is a cohort-based program that brings a diverse group of industry professionals together to learn about the urban stream framework. But this is not just a stream restoration course. It gets beyond that to help professionals understand relationships between watersheds, urban growth, infrastructure, ecology, and community priorities so they can make better decisions across the entire watershed, regardless of their role. The 5 elements form the basis of class material. The academy is fully in person and then meets 6 times with half the sessions in the classroom and the other half out in the field. With the Construction Management Academy, this is provides more one-off field experiences for designers, inspectors, and project managers to introduce them to waterway-specific construction materials and techniques. Sometimes it involves construction site visits like you see here. We also create hands-on opportunities where we can. One example is with void fill riprap, which is on the right image here. The void fill riprap takes conventional riprap and fills the voids with a dense gradation of smaller material. It essentially fabricates a mountain stream bed. This picture shows a contractor mixing a stockpile of the material. This photo shows some in place, and then this one with water flowing over it. So it's a loose material that can vegetate. I bring this one up because it's hugely beneficial in helping us create solutions that work better with nature. But it's really finicky because all the materials that get brought to the site are very inconsistent. So we created a scaled down version where the students mix and place the material by hand so they experience what can be challenging about void fill riprap. It takes a lot of field judgment. We also take opportunities to learn from contractors. This was a contractor panel where a group of them shared all their thoughts and feelings about working with all of us, which was great. We had 50 people in the room plus 100 people online. It was very popular. And then we also produce educational construction videos that get posted to our YouTube page, which you see here. Our riprap video is our most popular. It's been viewed about 75,000 times. So that's a little bit about the Mile High Flood District, our services, and some of our educational offerings. I'm going to flip this over to Holly now. We're going to play a little musical chairs. It's here. Okay, you should get.
All right, thanks, Dave. So we're going to go through a couple more example projects. And this is one that I worked on for quite a bit, evaluating safety grades at small pipes and culverts. And you can look at flooding like this, right, and think it's shallow. This is why we tell people not to drive into water. You really don't know how shallow it is. This is where someone was swept into a 36-inch pipe that was unprotected. This is what that pipe looked like. So on a dry day, it looks pretty innocent. Just note how little headwater depth you might have here. If it was a short driveway culvert, someone might be able to go through it and just come out a little shaken on the other side. Unfortunately, it was a long culvert with a utility cut through the pipe, which is not uncommon. And someone lost their life here. And so these are some of the dangers that we have in our watersheds on any given flooded day. ProPublica put some light on this a while back and said that we as government agencies have failed to take simple steps to prevent these tragedies from happening. So the first part of this project was that we looked at 41 different incidents from the 90s to the 2020s. And this was step one: identify the configurations and settings where people get hurt and how they get hurt. And then we were able to partner with Colorado State that built a physical model around this so that we would know, once we know where to install them, how do we design them? And we made lots of measurements in the Flume, looking at velocity at different points in the Grate before we partnered with the Larimer County Dive Rescue Team, who was really excited to get in the water and give us some qualitative data on what different flows felt like and what design configuration was easiest to navigate and self-rescue or help someone rescue, is, the role that they have often. Team was great. At one point, they convinced me to get into the Flume and see what it felt like, and it felt too safe in this configuration. We hadn't found that threshold condition that made it too difficult to self-rescue. So we changed it up, went to a vertical grate with an offset from the orifice, just to get the team closer to that suction force of the orifice of the culvert or pipe. We're looking for the force on a person that might pin them to the grate or suck them into a pipe if the grate wasn't there. So at 75 CFS in this configuration, you can see that our diver is able to walk in front of it and not lose his footing. Turned it up to 90 CFS. He noted that there was a dramatic difference. He said, quote, "It's hard, it's not easy for me." So now we know that between these two conditions, we've crossed that threshold force on the diver, at which someone might become pinned, unable to self-rescue. And then we partnered with AECOM to recreate these conditions in a 3D CFM model. And this would also later enable us to expand to more configurations when we're, so that we could expand to more configurations that we're not able to do in the physical model. So in the physical model, we looked at 2 different pipe sizes. In the 3D model, we were able to look at everything from 12 inches to 60. And we did some work to make sure we had agreement between the physical model and the 3D model, comparing measurements from both, and we're able to find agreement. And then we added a 3D person to the model to determine the force on that person for configurations we created in the Flume, specifically the force above and below the threshold force that we found at those different configurations that I showed you. So this is what it looked like. At that 75 CFS, we had a force of 107 pounds. And at 90, we had a force of 142. And so given that this was a full-size man in the Flume, wanted to be a little bit conservative, and we went with this was really a significant finding of our research, that 110 pounds of force is the threshold that you may get pinned against a grate, not able to self-rescue, or you might get sucked into a grate. And so now we know the threshold force. We can use modeling to look and better understand different configurations. We added a child-sized dummy into the 3D model for smaller pipe sizes. And then we want to translate this to criteria. So we focused on 3 different common configurations. Number 1, open pipe. When do you not need a grate? 2, flared end section with an off-the-shelf grate. And then 3 is that custom grate. And looking at the unprotected pipe configuration, that first configuration, we saw that discharges below 20 CFS didn't produce a force on a body more than that threshold force. But what if you've got really high headwater and you're restricting flow to 20 CFS? Maybe you're using the pipe to restrict flow and detain water upstream. That could be a very dangerous consideration. Headwater over diameter is a typical parameter engineers consider. We don't have force typically, right? But we do this calculation. And in our criteria, we've always had additional requirements for pipe inlets when this exceeds 1.5. We say, you need a headwater so that you don't have piping through the embankment. It's a threshold for other requirements. And when we looked at that within this study, we found that this 1.5 was also a good breaking point for evaluating safety grate design. Okay, so let's look at that second configuration, the flared end section. For the larger pipes in this study, 48 inches and 60 inches, the threshold force was typically exceeded for this entrance configuration when discharge was more than 100 CFS. For all pipe sizes below that, the threshold force can be exceeded when headwater over diameter exceeds a value of 2. And this means that for typical flared-end section designs, a prefabricated grate will be sufficient for flows that are under 100 CFS and with that headwater over diameter under a value of 2. And then that third configuration, the custom grate, when the design can't meet the conditions equivalent to the first 2 configurations, we found that the custom grate was always suitable for all other flow conditions tested up to 300 CFS. And so this is just a summary slide that shows that the criteria that we put into our manual for those smaller uncovered grates, they're good as long as it's under 20 CFS and you're within the 1.5 headwater over diameter criteria. You can go to a flared end section with an off-the-shelf grate as long as you're, again, within that 1.5 criteria and less than 100 CFS. And then between 100 CFS and 300, you can use the custom grate. And those that criteria has been incorporated into our manual. It's volume 2. We also have a technical memorandum that we've published on our website, along with AECOM's report and Colorado State University's report. We've done a couple of things with this, including work with some local students on so that resident scientists can come in and provide information on where these are located, and we can address them. And that's a bit about that project. And Candace has a couple more that she's going to highlight specific to stormwater quality.
Thanks, Holly. Great. All right. Hi, folks. Today, I'm going to be highlighting work of our stormwater quality program, and these are our main focus areas. So we update criteria that Holly was just talking about. We have 3 volumes, and we develop tools to support that, including design workbooks and other types of software. We conduct various types of research and special studies, like the street sweeping study that you're going to hear about. I'm also going to hit on our SCM monitoring program. And finally, we support our local governments with policy and regulatory issues, and we advocate and influence requirements and permits that are hopefully rooted in science and engineering. So I'm going to jump into some specifics here, starting with our regional street sweeping study. This study first came up through conversations with our local governments and state regulators, and this bubbled up as a good research project ahead of Colorado's general Phase 2 MS4 permit update. And both of these next 2 efforts were done in collaboration with Jane Clary at Right Water Engineers here in Denver, so a shout out to her. Goals of this project: we wanted to allow our local governments to take credit for the street sweeping programs they're implementing. And we also wanted to understand best practices that could be shared for better programs, better street sweeping programs. So we wanted to answer the question, how can we quantify and credit the nutrient reduction benefits of street sweeping in Colorado? And we developed this study. We wanted it to be slightly iterative. So we wanted our literature review and local government understanding of what they were doing to kind of inform our Phase 2 of field data collection and understanding the tool we wanted to develop. We knew we wanted a calculator tool to quantify, and we just needed to determine if we needed something new or we could reuse and piggyback off of some great existing research that's being done nationally. So we did that, and then right now we're in Phase 3 trying to finalize the tool and the report. So before selecting a technical approach, we really wanted to understand what data we collected would line up with existing municipal operations. We surveyed 12 MS4s and did some follow-up conversations, and we learned that most programs are housed in transportation or public works divisions rather than a stormwater program. All surveyed jurisdictions conducted spring street sweeping. Say street sweeping 3 times fast. It is really hard. It's a tongue twister. All jurisdictions do spring street sweeping primarily to remove winter sanding materials from our snow out here. Nearly all had dedicated fall sweeping or leaf management activities to get that up before the winter came. And most programs track collected materials by volume, such as cubic yards rather than by weight. Curb miles swept were attractive because they were already relatively easy to report, but we weren't really sure that curb miles could reliably predict pollutant removal. There were a number of other variables that we collected, but nothing really of note. And I think the biggest lesson here was that we needed the calculation method to meet the programs where they were at. And most programs can track curb miles and estimate hopper volumes. Far fewer actually weigh the material. All right, so what we were really trying to do is characterize the amount of sediment and sweeper waste that would be most readily transported to receiving waters and how much mass of phosphorus was in that. So we know the material in the hopper has been removed from the street, and the harder question is really how much of that material would otherwise have gotten to the receiving water as a phosphorus load. So perspectives on the water quality benefits of street sweeping range quite a bit, and it can go anything from giving a lot of credit because that material has been picked up to not giving a lot of credit based on what is actually making it to the waterway. So based on a literature review and current thinking, we felt that basing credit on fine sediment below 250 microns was a reasonable threshold. But there's also leaf litter, which complicates that framework because larger organic matter can move in runoff and release dissolved phosphorus. So we needed both a practical accounting method and enough regional data to really characterize. So we collected data with the help of our local governments. You can see some of the pictures there from both fall and spring. Our partners were Boulder, Denver, Golden, Thornton, and Douglas County. Mile High and project partners sampled 32 sweeper material piles. I want to give a huge shout out to our local governments. It was really hard to coordinate this. It was pretty tricky. You've got drivers running around and yeah, they were great partners. So samples represented mechanical broom, regenerative air, and vacuum assisted technologies. We did fall, spring, summer, and then a second fall for our sampling. And laboratory analysis characterized moisture, bulk density, organic matter, total phosphorus, and also the phosphorus in those different buckets of size fractions. So the biggest difference wasn't really sweeper type from our study, but really season. So as you're looking at those photos, fall sweeper material was lighter, more organic, and more phosphorus rich. And spring and summer material was substantially denser, which really makes a difference when we're thinking about that volume converting to a mass of phosphorus removed. We also found that only about 10% of the collected mass fit into that suspended size fraction, the 250 microns. But in the fall, 57% of phosphorus mass was associated with those larger particle sizes, likely the leaf litter. So once results were divided by season and sweeper technologies, sample sizes were just too small to draw strong conclusions about comparative sweeper performance, which we were a little bit bummed about. But next we wanted to answer the question, based on our data, do we need a new tool or can we borrow from others? And so we looked at curb miles swept and density to predict total material or phosphorus removed. And curb miles were appealing because they were already tracked and easy to communicate. But our data did not support a reliable pounds per curb mile swept relationship. As you can see there, there's an R-squared value of 0. So the relationship is poor, and this is based on a lot of different influences of source materials, accumulation, parked vehicles, operators, operating speeds, and a number of other things. And so this finding was important to the study process. It moved us away from developing a simple regional curb mile factor and towards a mass-based approach using seasonal measurements. And if sweepers if local governments don't directly measure mass, programs can estimate mass from collective volume using a seasonally appropriate bulk density, which is what we were studying. So this conclusion really narrowed the search to existing tools that use wet or dry mass and differentiate leaf fall from non-leaf fall conditions. And so in the search for a tool that might fit our data, the literature review, we looked at Minnesota, New Hampshire, Chesapeake Bay, and some others. We had originally considered developing a new Colorado tool, but after reviewing program operations and looking at the data, the team decided that actually adapting an existing tool would be a good option. And we went with the Minnesota Pollution Control Agency calculator. We selected this because it uses wet or dry mass rather than relying on curb miles swept. It distinguishes fall leaf litter from non-fall leaf litter, from non-fall collection. It's based on empirical data, and it uses the 25th quantile phosphorus concentration, which is a conservative basis for estimating that phosphorus removal. So some assumptions transferred well, others didn't. A couple of things we could guess: phosphorus concentrations were lower in our samples, as well as our samples were much drier. So that was helpful to let us know that we needed to apply our own data, as you can see there, for the calculator. So we're really excited to wrap this up. We've got a final draft and have this be a resource for our local governments as we continue to navigate the regulatory aspects of nutrient TMDLs here in Colorado. And some takeaways based on this Colorado study and the broader literature. Empirical evidence indicates that street sweeping can be not only just a good housekeeping practice, but it really can be a way to reduce phosphorus loads in watersheds concerned about TMDLs. We believe even more refinement might be conducted by our local governments with more detailed data collection to maybe actually get to that curb mile swept parameter, but we just weren't able to do that in this study. And then some of the national tools I guess this is the biggest point, some of the national tools can actually be transferable to other regions with regionally specific data collection. So you really don't have to reinvent the wheel, which was pretty cool. So I'm going to switch gears here. We've also recently completed the Colorado E. coli Toolbox. This was another project that was fueled primarily by supporting local governments around the general phase 2 permit update. And we knew the state was planning to include a number of additional E. coli TMDL requirements and really wanted to get ahead of influencing what those requirements might be by exploring changes in the state of science and practice over the last 10 years around E. coli. And what we continue to recognize after a number of entities in Colorado have been working on this problem for over 20 years is that there really are no easy answers, and focusing on controllable sources is the most pragmatic path. And you can work really hard on this and still have exceedances in stream, which is just kind of challenging. So we really tried to hit on practical tips in this toolbox and national information. We're really excited about it. Just want to go through a few things that were updated or that we found. So we gathered a ton of new information. We also found that a lot of the fundamentals had stayed the same, such as focusing on finding and mitigating sources of E. coli. We also found that some of the paths that were really up and coming, like some of the modeling for say had been found to not be particularly helpful over the last 10 years. And so new techniques are now being explored. And so in terms of developing a strategy, a lot of the general themes and best practices really hadn't changed. Address dry weather first, address human sources, do non-structural first, that sort of thing. One update to the toolbox I wanted to highlight specifically is guidance to support program development at various stages of maturity. This is something we identified when talking with our local governments and thinking about what permit requirements would be most helpful. And that really depends on where the program was in the process of understanding the issue. Getting started means understanding the problem and understanding things like who needs to be involved and your system and outfalls. A mid-program starts to consider what are our sources and how can we abate them, and consider systematic sewershed prioritization and investigation. And then a mature program is really going to get into adaptive management. We've explored our system and our sewershed. Now we're going to do projects and then come back and study again. So in terms of identifying sources, I think we were still on track with the information that was previously in the toolbox, but advancements included things like risk-based thresholds for the human HF183 marker, which I thought was super helpful. We get these numbers back in concentration form, and then we want to ask, what are these numbers telling us? What thresholds are concerning? When are these numbers bad? And so there's some guidance in there that I think is a really great tool and guidelines. Additionally, this table has been extremely helpful in conversations with the state about whether wet weather monitoring is valuable. Essentially, this supports the theme throughout the toolbox that the priority should be on identifying and mitigating sources. And wet weather is a challenging condition to try to look down sources. The concentrations are usually really high across the board. So we also present some innovative tools from various communities in Colorado and around the country. Denver's internal dashboard, where they have placed all of their E. coli program information as layers, was really innovative. They include information such as MST results, animal sightings, land use, inspection results, sanitary crossing points. And this really allows them to paint the picture of fecal contamination in their system and make more informed decisions. We also present examples of ways local governments are communicating risk and best practices to the public and recreators in these natural waterways. And some are even posting like red or green around different waterways. Additionally, an emerging tool to communicate real-time risk to recreators is being piloted by City of Boulder. I think City of Chicago was one of the original folks doing this, but using real-time sensor technology that measures a surrogate substance in stream. These sensors are around $1,000 each, and they're beginning to be correlated with E. coli concentrations. So you have more of a real-time understanding of potential contamination. So this is just a wealth of tools and information. I really encourage folks to check out the toolbox that's up on our website now. And finally, I want to jump really quickly into our stormwater control measure monitoring program. We've been conducting this research on facilities for a number of years, and we feel it's really important to do local applied research to understand how systems laid out in our criteria are performing in the wild and how we can improve criteria for designing with maintenance in mind. So we conduct various types of research, from internal sites to more summary regional projects to partnering with our local governments and academia. And we do this so we can use data to translate it into knowledge and ultimately wisdom that informs designs that are higher functioning, easy to maintain, and support our community values. So just want to run through a couple of sites here. Our 21st and Iris bioretention site. We've learned how a system can change over the course of a number of years, from vegetation to soil composition. The value of, so we've learned a number of things that we've incorporated into our criteria: the value of a sediment pad and formal forebay. Media with compost shredded paper exports nitrogen. So we made some modifications to our media guidelines. Internal water storage zones can reduce nutrients by promoting more infiltration and increasing contact time. We've included an internal water storage zone in our criteria, and just a number of other lessons learned, including lessons around monitoring specifically. Next, our River Run Park bioretention site. It's got a name from Game of Thrones, so it must be a pretty cool site. This is the partial infiltration bioretention with an under drain. And here we learned that spreading out flow along the length of the system would have been more advantageous to treat and not overloading the beginning portion of the system. We just got a ton of sediment in that front portion and therefore weeds. The forebay at the site was undersized and allowed too much sediment into that kind of front area, clogging the media. And it's also hard to access to maintain. It's also kind of challenging from a monitoring standpoint because we don't get outflow because it's such a well-performing system. So good example in one way, but we're not getting the outflow data in another. Moving on, finally, I want to highlight our MHFD campus updates. We're currently engaging in a project to update landscape and exterior areas of our campus. Dave Skudis is actually leading that project for us. Our vision is to really make this a learning and research space from stormwater to vegetation. We're working closely with design engineer and landscape architect and also the Denver Botanic Gardens to develop stormwater control measures and vegetation that will be monitored. Some facilities will also be more of a demonstration of aesthetics and best design. And we want these spaces to provide training opportunities that folks can go out and learn from. Also considering what we might want to change over time and control, and we're including that in these designs. So it's just been really fun to inform that. And we anticipate going to construction in early 2027. Yeah, and so that is what I have. Dave, do you want to? Okay, here we go.
Yeah, no, it's great. We'll do any questions. It looks like there's one I answered in the chat. Looks like there's one that I'll defer to Holly or Candace to answer that's in the chat. I'm not sure if we can see it.
For bioswales, how consistently do communities perform maintenance, and what are the typical costs incurred in upkeep for smaller communities? And what does it look like? Additional staff to maintain landscaping? Question mark. Oh, I would say on the Iris site, one thing that we learned from that was that these do require maintenance, and I'm not sure if you're a local government and you're putting them in front of a residence, you need to have a plan. You know, we found that really on a monthly basis, we needed to clean out the sediment pad there. And I think the best way to do maintenance on something like that for a local government is, how does it work into the work you're doing throughout your watersheds? Yeah, did you want to add anything on?
No, I think that's good.
Or...
I just want to throw it out there. Holly led both of the projects that I mentioned for the our two monitoring sites. So she is the expert on those.
I might go ahead and read that question and the answer, just in case there's folks on here that can't see the Q&A. The question from David Rothwell was back to the first segment on stream channel restoration. I assume that this often triggers loamers for the project shown. What was the cost of the loamer relative to the overall engineering? And secondly, do these projects typically count as mitigation credits? And so for the Cherry Creek example, the construction cost was 10 million. The consultant cost was around 2 million for both design and construction management, within which we paid around 150,000 for the clomer and loamer combined. Did not achieve mitigation credits for the project that could be applied elsewhere, but are looking towards that goal on another project, specifically for stream mitigation credits, but not wetland mitigation. So just getting that out there And thank you. I'm assuming that was David and not Candace that typed that while she was talking.
I'm not that talented.
That would have been impressive. We have additional questions. What were the main drivers on the Cherry Creek project if it didn't receive stream mitigation credits? Does Colorado have separate point source stormwater credits versus non-point source mitigation credits?
So that project was driven by a desire for stream restoration. That was an area where the floodplain was pretty contained on the site already, but the stream was eroding like crazy and starting to threaten the trail and threaten adjacent roads. So that particular project wasn't driven. Water quality improvements wasn't a catalyst for the project, but in designing the project to use a more nature-based design, if you will, more vegetated approaches. There's a lot of buried riprap along there. It was kind of during the project where somebody figured out it was a good idea to study how much of a water quality benefit the project created that was analyzed by right water engineers. So when the question was brought up about credits, my mind, I'm more of a infrastructure guy and flood risk reduction sort of focus where I come from. So when I think of credits, I think of 404 realm. So when I answered the question earlier, it was more from a 404 permitting credit sort of point of view versus MS4 related. So
I would add to that in that phase 2 permit update that is happening, we are looking at stream restoration as getting some credit for phosphorus, for nutrient TMDLs. That's not currently in any of the permits, but we feel like that is something that is super valuable to water quality. And there have been some research papers that have been published about that, but it's not really in the regulatory realm yet, but we're hoping to advocate for that.
Yeah, and it's why we study this, right? It's why we make an attempt to calculate it as we did on this project, so that we can support that kind of change in the permit.
Right. Do you have any publicly available documents and reports to share?
in the words of El Guapo in the movie Three Amigos, we have a plethora of publicly available documents and reports. We'll I think maybe what Candace and Holly and I will do, we'll create a handful of links we'll share with Jason that you can share out with the attendees. Maybe that'd be the easiest way. So you're not just searching in the forest. Yeah.
Yeah, and we'll post that on the YouTube channel where we put this on there too, so that way when people watch the video in the future, they can get right to that. I very much want to thank you guys. One of our overall goals for the Great Plains Stormwater Center of Excellence is to connect innovation to stakeholders across the region, and that's exactly what you guys have done today. You're doing some super cool stuff. Holly, I almost want to say you did a great study, but you probably heard that 100 times already. So, I did have a couple questions on your academies, the Stream Management Academy and the Construction Management Academy. Can folks from outside of your area take that class if they want to?
Traditionally, the Stream Management Academy has been only in Colorado. We've been doing it for, I think, about 10 years now, and I think, it's time where maybe we could be open to that. There are, I think the number of times we meet is, because sometimes we have a class day and then a field day back to back. I think it's somewhere around 3 to 5 different times that the class meets. So if somebody were coming from out of state, they'd have to, plan for that kind of travel. Last year, we did do it as a hybrid session where it was the classroom parts were in person, and then there was a webinar group hosted simultaneously. And what we found was it made the experience for the in-person attendees and the online attendees not quite as good. So one of the things we're hoping to put out maybe next year would be probably a standalone video of the different sort of classroom content at least, so that would be more widely available. So, but it would be, each of the 3 videos might be 25 minutes long. So we're working through the scripting of that, which takes some time to dial in the way we want to do a good job of it. So that's one thing I would offer. The Construction Management Academy has typically only been in person. They're usually one-off sessions that are an hour or 2 to half-day sessions. But that's where we already do have, I think, 5 or 6 on-demand videos that tend to run about 10 to 15 minutes long and get into some really great information about some of the techniques I was mentioning. And we also have construction guidance documents on our website as well. So I'll send links to those. Will be some examples of things I'll send links to.
Right. We also have a Colorado page for the Great Plains Stormwater Center of Excellence with resources, and I'll talk to Jake and make sure we got all your guys' stuff on there. I bet you we have quite a bit of it already. See a question on here. Was the Cherry Creek project funded by MHFD, and what funding mechanisms would you suggest for stream restoration in rural Colorado communities?
Yeah, I believe that was fully funded by the foot. I wasn't personally involved in all the nitty-gritty of that project. I'm more like aware of a lot of things. So it's primarily City of Denver and Mile High Flood District. I think they might have gotten a grant from the CWCB. So I think for rural communities in Colorado, the CWCB would be a great resource for funding. I could point you to as a starting point.
Okay, and the question also asked WSRF funding question mark.
It sounds like the state revolving fund. I assume that's what that stands for. So that's going to start getting you into federal funds. And if your choice is no funding and federal funding, then of course go for the federal funding. Just know that it creates administrative burden that more local funding sources, they're not as burdensome. But if you have no funding versus federal funding, then of course go for it. Just know that going in, you might need some help with the administrative burden.
All right, another question here. What are the key limitations and uncertainties associated with the pollutant reduction credits attributed to street sweeping? Are the reported credits presented as a range to reflect variability in factors such as sweeper efficiency, debris composition, seasonal conditions, and measurement methods?
They are not a range right now. Again, this is hot off the press, so I am trying. There's more review that is needed, I think, of the tool and just making sure. I think a range is probably really appropriate given, the level of uncertainty and just applying these densities to volumes seasonally. So, and then let's see. Hold on. What was the first part of the?
What are the key limitations and uncertainties associated with the pollutant reduction credits attributed to street sweeping?
I mean, I think it's just the nature of how different programs could be and sweeping different areas. I mean, we just saw a ton of variability, in aspects of the data, and tried to do our best to kind of corral that into something that's workable. But I guess I was pretty frustrated that we couldn't say more about the different individual sweeper types. And then, in breaking it down with Jane Cleary, it was like, well, if you go by season, we really only have a couple of samples of each type. And so it just is really data intensive. I think to get a data set to use in this way. So, but I think we're still pretty pleased with this, and the way it's going to likely show up in permit requirements would be more in a programmatic way. We're hopeful, at least for this round of permit, more like have a program, measure the pollutants you're removing, report that, and we'll kind of see what happens as that evolves and adapts. So,
right. Well, we are past the top of the hour. I do have one more question I want to get to you, so we can get it on the recording here. For everybody that's on here, this presentation has been recorded, and we will be posting this to the Stormwater Center of Excellence YouTube page. And so that will be out there through our website, which is gpstormwater.org. gpstormwater.org. And so we'll get that on there along with some of the links. And the last question If you guys have other questions or want to send it to us and we can forward it on to Candace and Holly and David. But the question here is, this was a great presentation. Thank you. With the project shared here and the community involvement somewhat at the start for some of them, what were examples of ways you all set realistic expectations for the community to understand working and maintenance with nature may not have a consistent look?
Yeah. Well, I can say that that's something we're still working on in the Uvalde project I showed with the street median getting widened. I was out there. I was actually out there for the ribbon cutting, and somebody drove by and yelled something about picking weeds. And somebody in the group, actually a resident that was sitting there at the ribbon cutting, said that people there aren't used to what natural native vegetation looks like, and they kind of expect sod. And so it was kind of this aha moment of maybe we could have done a little better job on that point of what to expect the vegetation to look like. And so I think with the AI tools and different things we have now, like creating realistic renderings is a lot easier than it used to be, and it used to be so labor intensive with so many mouse clicks. And so I think that's something we're still working at, and I think we could do a better job now with how much easier it is to make renderings of to expect things to look like.
Great. Well, thank you everybody for joining us today. Our next webinar in September will be another one of our virtual open houses where we talk about specific projects and get feedback related to things that we're doing for the Great Plains Stormwater Center of Excellence in breakout rooms. A chance for you all to really contribute to the things that we're doing and give us direct feedback while it's in progress. So look for that coming out. But once again, wonderful presentation. Really appreciate you all. And see you next time.